Woohoo! Prusa XL is here! Why am I so excited? And there is a video. Haha, rant time. Jokes included. Whoa, look at how much filament you're supposed to have. People say I have a lot of filament. Look at this. I don't have that much more than this. It can print. Oh, it's a 3D printer, I get it. Whoa, this is serious. I need hydration. I just discovered kombucha. It's got green tea. Tastes like medicine. Good drink. Flex plates, yes, love it. I want all the printers to have flex plates. All of them, except the printers 3D printing buildings in concrete. I don't think a building could make much use of a flex plate underneath it. Or would it? CoreXY design, love it. There aren't many choices for a large build volume in a compact printer. CoreXY printers have been gaining traction with projects like the Voron and Beak 3 here. This doesn't look like a printer yet. Less way to move around, all motors fixed in place and away from the hot air, except for the extruder. The trade-off is the long belts. They're tiny little bit elastic and can vibrate. This kit comes with 9mm belts, and I even have 12mm belts for a project, but the Prusa XL belts appear to be only 6mm wide. Is it good? Is it bad? Will it matter? I don't know. But the frame, no vertical extrusion at the front and no horizontal connection either. Does look awesome and super user-friendly, but how not to make a rigid frame? Is this Joel type Ender 7 with a curtain? I'm holding Joel accountable for this. I saw him near the printer with his angle grinder on him. He was ready to chop it off. I'm scared. How do you 3D fight angle grinder equipped Joel? Build volume. Here's the build volume for a Mini. I created this visual representation using a patent-pending proprietary technology. Here's the Mark III's. Here's the XL. And here's my Beak 3. Wait, forget about the Beak 3. Here's the XL, the biggest of the smaller ones. I know some people say they never print large parts. Tom once said that he never prints more than 10 centimeters tall. I don't know if that's true, but what I do know is that my designs tend to be big. My dry box has a lot of compromises to be able to fit it in a normal build volume. So if you're not happy with your expensive 3D printed dry box, don't blame me, blame the box. Bad small printers. But this build volume... All the cosplay costumes, helmets, weapons, large mechanical parts, industrial prototypes. If I 3D print a plane full of real people, do I print it flying or laying on the bed? First layer calibration. Finally! This alone slashes the number of Facebook posts in half. No more super mega pinda. The nozzle is the probe. Beep. Tried and true on my Creality CR6 SE, same thing. So I'm happy that Prusa included this load cell sensor. Internally developed load cell sensor. Okay, still this might be my favorite feature out of the whole thing. Because live said. Modular bed design. Unexpected, the bed design is a big topic because flatness for minis or ornamental things, mesh leveling compensates for the uneven bed and all is good. When you print parts that need to perfectly align together, well, it's a different story. For my Mark III's, there's the Nylock mod, where you make 8 out of the 9 mounting points adjustable and use software resistance to level your bed and get it really flat. Then you realize that both Z motors share the motor driver and often get out of sync in between prints, at least mine do. There's Z calibration which doesn't really fix it. Anyways, can I adjust all the 64 mounting points? For the bed you usually get a big fat piece of cast aluminum so there's no internal stress, rectified to be somewhat flat. Grows or shrinks slightly as it changes temperature, so find a way of dealing with that and you got yourself a flat bed. Well, mine isn't actually that flat, but... Where was I? Can I adjust all the mounting points? Will the printer assist me with this little endeavor? Will it take forever? I'm dying to find out. Figuratively. So with this modular bed, each piece expands independently when heated. There are little gaps to allow for this thermal expansion. Good, because a large piece of PCB would likely warp. But there's a large steel sheet plate on top, which also expands, and it's just one piece. So which way does that expand? Whichever direction is easier to slide? But no worries, just preheat to the right temperature and stay there during printing. But what happens if you only heat up some of the modules? Oh, we haven't reached that part, wait for it. The bed can be either fixed with the extruder moving in 3 dimensions to reach all the places, or it can move up and down, which is the case here. You can have a 3-point mounting with independent motors to level your bed if it happens to be tilted, or have less motors with no way of auto-leveling the bed. We've got 2 motors here. See the lead screws on the sides and 2 linear rails? Do they share a driver like the Mark III's with no possibility of leveling? Say no. Say no. How I want this to work is to use independent drivers and have some screws to adjust the front and back tilt, and let me adjust all the 64 screws for perfect bed leveling. Can I have that, please? Because my stressed out neurons are about to pop out. Yes, so there's modular heating, which is cool for when you want to print something really tiny and you only want to make a tiny fire underneath so you don't waste a lot of wood. There's no wood. Forget the wood. But heat tends to spread out through the metal sheet, so well, there is less heat lost from the bottom side, if not insulated. Why is it not insulated? Anyways, nitpicking, just let me get the bed perfectly flat, okay? Wait, 16 independent cells means 16 bed thermistors. And the ones on the outside can work more to keep the heat uniform. Well done. This is starting to look more like a mining rig, but for Prusa coin. The bed is not mains powered, which is safer, and then what kind of power supply is this running? Monster power! Then comes the Nextruder. Is this a Kickstarter name? Zero backlash cycloidal gearbox 20:1 ratio. Is this pure marketing material? Prove me wrong, but hear me out first. Small diameter hopped gears come with downsides. I made multiple videos on this and I linked them in the description. So they wanted a bigger hopped gear, about 2.3 times larger. We've seen the same approach with Pontex LGX earlier this year, but there the gear teeth are rounded. I'm guessing because the filament is round, but here they aren't, so... Anyways, to transfer the same downforce on the filament with a larger gear, you need 3.2 times larger torque. You also want a lighter and more compact extruder, so you use a lower torque pancake motor. On geared extruders, you see ratios between 5:1 to 7.5:1, but for driving the larger gear, you need 3.2 times the torque to achieve the same downforce. So between 16:1 and 24:1, and 20:1 is right in the middle. Well, it's not exactly in the middle. Anyways, 20:1 is an expected gear ratio here. Took me a while to get here, didn't it? A 20:1 gearbox would be bulky, unless you make it cycloidal. Ooh! And you get a very compact gearbox, which is known to create a lot of vibrations. A cycloidal gear uses an eccentric bearing. It'll vibrate at high speeds. There are ways to mitigate this, and I can't wait to learn how they got around this known issue. And I'm hoping the solution is not to print super slow. I'm fine with my Mark III's printing overnight, but with this kind of build volume, I don't want to be printing for a week at a time. So there must be a solution that I'm missing. So if you want to get rid of the hop gear issues, you need a larger gear, which means more torque, and then you use a smaller motor, which leads to the 20:1 gear ratio, achievable via the cycloidal gear, which gear can feature zero backlash, just like the marketing says. Which we shouldn't care about at all, because extruders tend to extrude only one way, and we don't need micron precision with a retraction. But it doesn't hurt either, and is good for marketing, if it doesn't vibrate. Hydration. This might look like beer. It's because it is beer. Zero alcohol, which means I can't use it as an excuse for what I say. Also says no slip. To take a step back, the extruder has to push the filament into the hotend, and there's gonna be back pressure. So it takes quite a bit of force to convince it to squeeze through. Explained this in another video, but in short, the filament can start slipping on the gear. One choice is to use dual hop gears to distribute the force. Earlier I was running a flow test with this Rapido ultra high flow hotend, and I was pushing close to 70mm cubes a second with almost no slip. This is insane! I pretty much never get slip with well-positioned, well-tensioned dual gears. And Prusa Mark IIIs does use dual gears. I guess they're now out of fashion, so we're back to single gears since the Mini. And here to compensate, the Nextruder uses two idler bearings to push the filament into the gear for more grip, and that leads to the filament bending here. Belt extruders exist which use a curved filament path, so this looks like a neat solution. But will it be easy to load flexible filament? And will it work with brittle filament? I've got a lot of filament, and some of it becomes brittle no matter what. Keep it dry, put it in a dehydrator, sing it love songs, it just becomes brittle. That won't prevent it from extruding just fine on my printers, but for this filament path it only takes one snap to ruin a print. I didn't make the piston extruder because my Mark IIIs was running too well. I know some filaments are better than others, but I also know that my extruders work with pretty much any filament and the stock Prusa ones don't. So I don't really buy the "oh, it's your filament" story. Not saying one should use cheap filament. I love my Prusa, but I also like to have different options for different projects. But hey, they probably studied this stuff more than I have, and could turn out to be an awesome solution for the filament chewing. And behind all the marketing and numbers, I do find the solution attractive, because I believe the aim here is to fix a known extruder issue, and that's wonderful. And I'm hoping that everything has been well tested already and we won't have to worry about filament snapping or extruders clogging. Which takes us to jam detection. If you can prevent it, you can at least detect it. But in all seriousness, this is a neat thing to have. Although I can't remember the last time I got a jam. Do you know something I don't know? But what I do know is that hotend swapping is a trending topic. I know a guy who designed an entire extruder around swappable hotends. Looks fairly easy to do on the Nextruder, although I get a feeling that it takes more than unplugging a connector. Do you know the recently released Revo from E3D which aims at quick swapping nozzles? For the XL, we're also swapping the heater block and the heater cartridge and the thermistor instead of just the nozzle, but not the top radiator. So it's not like you can plug in anything other than this custom-made hotend. Heat creep detection. Well, added safety, cool. I like safety. So what's the reason for the added safety? What happened before the safety? Oh, prevent heat creep issues you might see in other printers. Oh, I hear MQTT and big data. Is the printer spying on me? It can tell when a clog is coming. I'm telling you, the end of the humankind is near. What's worse than a self-conscious robot? A self-conscious 3D printer. Cooling fans with RPM monitoring. As before, nothing new, but many of my 3D printers don't have it, so thumbs up for safety. Breakout board. Yes! I wholeheartedly love the idea. I work with extruders all day and wiring is the worst. Always wanted a good and compact breakout board. This one's got a bunch of connectors and it's way more than just a breakout board. I only wish it was a little bit more compact. I know I'm nitpicking again. I know I'm nitpicking again. My extruder customization brain does that sometimes. Fitting it in an extruder is not easy, but works just fine here. The idea is not new, we've seen it in a Mutant, where you manually swap hotends, and it does include all the connectors just like here, except that one does not require additional electronic parts on the board. Overall, I'm really happy to see a breakout board here. It's gonna make it way easier to swap components, with other Prusa custom components for now. Oh, quick-swappable electronics, 32-bit. Yeah, okay, 32-bit is not really a new thing anymore, even for Prusa, but quick-swappable boards. This reminds me of building my custom PC computers. So you plug this in and they expand the number of tool heads. But there's an entire electronics board at the tool head that's supposed to do all the things. And then you need another electronics board at the main board? I must be missing something. Do I see 3 stepper drivers on this one here? Maybe it's not one per tool. I'm intrigued. But why do I want to quick swap them? Color LCD screen. Amazing. You call a screen color when you can't call it a touchscreen. Hey, works on the Mini, will work here. Same UI, only it's in landscape position here, because it's a CoreXY. This means Prusa firmware, which is Marlin derived. Tried and true, but also missing some new features like resonance compensation and less customization. Nothing to worry about. It says here they are considering an official Clipper firmware. Considering. What does it mean? Oh, Prusa Connect, web interface for remote printer monitoring, I guess. So you can check that the heat bed temperature is unstable. So I guess you can just connect the XL there, just like you use Prusa Slicer to slice files for it. Anyways, what I know for sure is that I'm not on the early access list. Maybe it's the equivalent of Octoprint or one of the Clipper interfaces, you tell me. Super high quality linear rails. Yep, time to ditch the flimsy rods. Oh look, layer lines. Spool holders, who knew? Look at the size of this spool, where do I get that? Also filament sensors, excellent. They detect filament runout. Do they also detect spool jams? It's different from a hotend jam, so I wonder if it can figure that one out. Power loss recovery, so it can resume printing after a power outage. Power outage. Handy feature when a storm hits your power lines 22 days into a slow print, unless you're printing from Octoprint, in which case you've got a UPS or you're screwed. Is there a third option? Has this power loss recovery been improved? I vaguely remember an issue with vase mode and power recovery and permanent memory and artifacts. Or am I not up to date with all of this? Tell me this has been sorted. RGB lights? Yes. Positioned at the top so that the print is lit at an angle and I can see the layer lines here. See? And the vertical lines here and here that immediately remind me of my Mark III's. Hey, to be frank, this is a non-issue for most people. But I'm not most people, and I'm afraid my smooth surface obsession will not tolerate this. But let's be real, whoever has to print such a large nut and bolt has bigger problems than those layer lines. Slicer profile. Yes. Look, I changed all the settings in this slicer. With good hardware, having good profiles is not that big of a job really. And yet, other printers can come with horrible printer profiles. I'm starting to believe that some 3D printer manufacturers have never actually used their products. Do you think China can hear me from here? Same goes for filaments. You might know about temp towers and calibration cubes and bridging tests and torture tests. I don't understand this dialing in thing. I've got a lot of stuff to do. I have like 5 minutes to pick a nozzle, build some new filaments, slice the files and hit print. If you have more free time, you are welcome to visit me and make profiles for all my hundreds of filaments and all the extruders and the printers. At least with Prusa, there's one profile that always works and I use it all the time and be done with it. Having said that, I don't really use these fine-tuned profiles, but they're a good start for someone entering the hobby, so thumbs up for that. 1.5, 3/4. International warranty and support are great and good peace of mind. I sometimes reach out to their support with the most obscure of issues and, well, they sometimes can't help me, but I always appreciate their attitude of trying to help. Optional add-ons, upselling, I like it. Yeah. It won't tell me what the add-ons are. Mystery. A very long PDF YouTube from their factory to my place with pay-as-you-print plans? Good thing they'll be revealed before shipping, not after. Oh no, look, I found it. I'm so smart. Draft shield and enclosure. Is it this accordion style cover? The top is to stay open for all the wires, so heat rushes up and creates turbulence? Neat. But there's an enclosure. Where's the enclosure? Does it go on the printer or around the printer? Heated chamber? No. You know what? I'm thinking that with all the work from home thing, this draft shield is secretly there so that you can print not safe for work stuff during work hours. Nah. Are you at work now? Then boop the like button. Oh right, the toolie changey. Very nice and extremely precise. There's a center lock like with E3D's tool changer, but it loads the tools with a side motion. Prusa tool changer. Oh, the calibration. Fully automatic tool alignment. Absolutely love it. I've researched this subject because I'm facing the same issues with my engine swap project. So they're using this metal piece thingy, which I assume it locks in place on the bed, combined with a load cell to first measure the nozzle Z height, and then it measures the conical shape on the outside of the nozzle at various angles. This is pretty much the best solution that I know of. You could test for electrical conductivity or use an accelerometer, but since the load cell is there, why not use it? Should be very precise. There will be filament residue on the nozzle, so it has to be heated up. And then there will be residue left on the metal thingy, so melt that first. This alignment routine has to run outside the printing, so it has to store the XYZ offsets in the printer and look them up during printing. So every time you change a nozzle, for example, you would have to run this routine, I presume. I so love it that it's fully automated. Position the metal thingy, press a button, and it can do all the measurement at once. Just let me know when it's done. Perfect. So now you can print with multiple colors and materials. Maybe you did that before with the multi-material unit. I tried it and found it way too fickle and I ditched it forever. But with multiple tools, it's a different story. MMU2S has more than 93% success rate, whereas the tool changer completed over 500,000 changes without a single hitch. Take that, MMU2S. And no purge tower, maybe. I wonder what happens to the oozing and if there's nozzle priming before loading the tool, and if there's a brush to clean the nozzle before printing. How does it all work? Do you know? Does Prusa know? There's a ton of custom hardware in this printer. The entire extruder, the hotend, the bed, the breakout board, the electronics board, the tiny metal thingy. I imagine this keeps the costs down while optimizing the hardware as much as possible. It also means that any customization will be harder to do. And if you happen to own a bunch of hotends from other companies, none of them will fit. So we'll be stuck with what Prusa has to offer, which won't be a problem if it meets expectations for most customers. Okay, is this open source? I know Prusa is big on open source. So is it 3D and now the Revo is not open source? And I couldn't find anything on Excel. So is it open source? Is it not? Or is it? Or is it not? Or is it? Or is it not? Remember when I said Prusa XL is here? I lied. It's shipping Q2, Q3, 2022. But you can pre-order right now. If I know one thing for sure about this printer, is that my brother already pre-ordered the maxed out version. But have you pre-ordered it? $20.99 for one tool head partially assembled and €36.99 for 5 tool heads. Well, it's less than I thought it would be. They're gonna sell like hot printed bread. But is it a little? Is it a lot? You tell me. Feature-wise, this looks like a home run. Is that why I'm so excited? But kinematics-wise, what I'm most enthusiastic about is that this is now setting the bar for all the other 3D printer manufacturers. The pressure is on, and we'll be getting better and better printers. Well, congrats to Niklas for the awesome video production. Not this video. This video. But I've got so many questions. Will it be fast? Will it high flow? Can I have even more colors? Will it work with the MMU? Will it work with the palette? Are we getting a Prusa-let? Will it print pancakes in the form of a kitten? Oh look, says here Prusa XL. What? More on Friday. Stay awesome. Load sense sensor. Load sense.